I'm going to show you how you can make your own phylogenetic tree or your own family tree, okay? It's a really cool lab. So the lab actually is posted, that's what I was working on. I just posted it in your course outline. So if you look at your course outline in terms of what we're doing, okay? So right now some of you are still working on the cobweb lab, interfish series. It's this one. It's the NCBI assignment. It's not totally complete. There's going to be a second part, okay? The first part, which is right here, is looking at making trees, not the trees with leaves. Okay, Lauren? So we're going to look at using a website called NCBI. You can draw it if you want. And we're going to build our own trees using this website. So let me show you that in a second.
I think he's trying to feel very download.
Okay, so this site is a pretty amazing site. I came across it years ago when I was trying to give my students real-life examples of genomes, and I came across this site, and I've been using it ever since. It's a really cool site. It's I'll be honest with you, it's used from anywhere from high school all the way to scientists, researchers, PhDs, people at universities. So some of this stuff is very technical, but you don't need to worry about all the technical stuff, okay? I'm going to show you what you need to worry about. This is basically like a dumping ground, but in a good sense. Remember in the video when you looked at the human genome, they said that it's freely available and that people anywhere around the world could look at it. So if you do some research on a protein or a gene and you sequence it, the letters or the amino acid sequence, you can post your information, and then someone in Russia could look at it. We're going to be using all of this data, and we're going to make our own trees. Okay? So what we're going to do is we're going to use part of the site. Okay? So the steps are, you're going to click on what's called homology. Now, homology, remember, homologous means things coming from a common what? Common ancestor. And then we're going to click on something called homologene. Now, don't worry if you're like, I missed that, sir. Never, I'm recording this, okay? Okay. It's called homologene. Now, I'm going to give you an example of a gene that you're probably familiar with. Sonic hedgehog. Okay? So, I'm going to type in Sonic hedgehog and I get a hit. Now, you might not get the same hits. You might get different hits, but I'm going to tell you what you're going to do with this, okay? So, these are a list of organisms that there's data for this gene. And actually, what we'll be looking at is the protein sequence of the gene, okay? These are different organisms, so what do you think that is? That's us. That's a chimpanzee. That's a macaque. Okay? It's a primate. That's a dog. That's a cow. That's a mouse. That's a rat. That's a chicken. This is a frog. This is a zebrafish, type of fish. And this is a fruit fly.
How did you know that?
Man, I'm a lot older than you guys. I know there's a few things I know that you don't know. Okay?
Yeah, it's usually how we know that you don't know.
That's true. That's true. I didn't say that. I didn't say that you didn't know anything. But there's a few things I said. There's a few things that I know that a few. Okay? All right. So what we're going to do is we're going to download this information. So I'm going to go and I'm going to download it. So here is this box. Now, what I'm going to do is I don't want to burden you with having to analyze too many things. So what I'm going to do is I'm going to say, okay, I just want to analyze a few organisms. And I believe in the outline I say pick 5. Okay? So let's say we pick humans, chimps, those two are primates. Let's pick a dog. Let's pick a mouse, a rat, and I'll do 6. You don't have to do 6, okay? and I'll pick the zebrafish. So I got 2 primates, I have 2 rodents, and I have a zebrafish and a dog. Okay? Yeah. Now, what I'm going to do now is I'm going to download this. And what it's going to do, it's going to put it in what's called Notepad. At least I hope it puts it in Notepad. Where's Notepad? There's my Notepad. Okay? Now, what you're seeing here is nonsensical. Right? You're like, what is that? Okay. So, I see, okay, so here's the name of the protein. I see, okay, and there's the sample, Homo sapiens us, okay? And then, so wherever you see this little symbol, the less than or greater than symbol, then this line here is just the information about the protein, where it's from, what it's called, okay? And then all of this is a list of what are called amino acids. You learn in grade 12 that a protein is made up of 20 amino acids. So the letters represent amino acids, okay? Now, there's a whole table. I don't care if you know what the letters stand for, but generally, if it's a different letter, it's a different amino acid. So like F would stand for something, L would stand for something else, okay? No, you don't, okay? Now, what I'm going to do is I'm going to create a family tree, but the problem is when I create my family tree, it will use this as my label, and that's a really big label, okay? So what I'm going to do is I'm going to trim the label by just leaving the name of the specimen. So I'm going to do this, okay? But I have to leave the symbol, because otherwise the computer will not know that that's just the information of the protein. So I leave the symbol, I leave the name, and I'm going to do that with all of it. And what I'll do is I'll show you one that I didn't do it with too, and you'll see the difference, okay? So I'll do it with the dog. Okay. I'll trim the mouse one too. I'll trim the rat. And I will leave the zebrafish as is, okay? So this is what I'm going to do now. This information, I'm going to get the computer and analyze it, okay? I'm going to pick the humans as the reference point. So I'm going to take the human sample, and I'm going to copy this. Okay, I'm going to copy it. I'm going to go back to my my NCBI. I'm actually going to go to a different part of the site. So I'm going to go back to the NCBI, and I'm going to use a feature called BLAST. Now, BLAST is an algorithm. It's a thing that will take a sequence and compare it to other sequences. And it will look at the similarities and differences between the sequences, okay? So because we're using a protein, I'm going to click on Protein BLAST. So it's gonna take one protein sequence and compare it to other protein sequences, okay? So I'm gonna click on Protein BLAST, and I'm gonna paste in that sequence, okay? That's the sequence for what? Humans, okay? Now, because I have more than 2 sequences, I'm going to, where's the align 2 sequences? Oh, here we go. So I'm going to click on align 2 or more sequences, and then another box pops up. What I'm going to do is I'm going to put the other 5 in that box. Okay? Yep. Because we're going to compare the human to those 5 sequences. Okay? Now you don't have to do the human. You could pick the zebrafish to those 5 sequences. Yep. It's going to make the graph for you. Okay? So I'm going to copy and paste. That's okay. That's why I'm recording it. Okay. So right now what I have in the first box is, you can see the label for humans and the sequence of the protein sonic hedgehog in there, right? And then for my other box, I have all of the rest of the organisms. Okay? You can see the zebrafish, the rat, the mouse, the dog, the chimp. I hope you can see from where you are. Yeah. I'll show you, because I didn't shorten one label, okay? It doesn't change the tree, but just the label is going to be really, really big and might get cut off, okay? So this is what I'm going to do now. I'm going to click on blast. Now, I'll be honest with you, sometimes it depends how much traffic there is on the net. It could be a little while. This one seems to have turned up pretty quickly. Okay. We have some numbers here. I'm not too worried about the numbers. What I'm interested in is a tree. So what this has done is it's compared the human sequence to those other 5. And it's going to give you what's called a distance tree. So I'm going to click on distance tree. Okay? And it's going to put this in a tree so you can read it. So here we go. I think. Here we go. Where's the tree? Okay, there we go. Now, here's one way to look at it. I tend to like the slanted version. So I'm going to change this. Where is the option to change the alignment? Oh, where is it now? Hold on, let me pause this. Okay, sorry about that. So, okay, so I figured it. So this is the rectangular version, which is fine. You can leave it like this. I just kind of like to look at it differently. So I'm going to click on, for my layout, slanted cladogram, and it puts it like this. This looks like kind of like this now, just on its side, right? So it looks very similar. Now, you'll notice the labels. This is the one that we used as our original, and we compared the other ones. And then look at that label there. See how really ugly it is? So that's a disadvantage if you don't trim the label. But remember, always you got to leave that symbol in there, okay? Now, this tree shows us a few things. What it does is it puts together things that are similar, close together. So remember how what we did. We took the human sample, we put it in one box, and then we put the other 5 samples in the other box. And what the computer did is it scanned the human version versus the chimp version, and it said, this is how similar it is. And then it scanned the human version versus the dog version, and this is how similar it is. And then human versus rat, this is how similar it is. The ones that are more similar get put together. The ones that are more different are further apart. So you'll notice, here's your chimp, here's your human, this is the common ancestor. That would be the hypothetical common ancestor of humans and chimps, right there. This is the dog. You'll notice that the dog, the human, and the chimp would share this point. So this is saying that the dog is closer to the human than the rodents are. Because if you look at where the rodents are connected to humans, the point that connects rodents, dogs, humans, and chimps would be this point. If you think of it as a tree, it's the branch point. Okay? So what connects the rodents together? The branch point would be this one. What connects all of these together? It would be this branch point. The points would represent like a hypothetical common ancestor, last common ancestor, okay? So 2 things are more like each other if their branch points are very close. So you could see humans and chimps share this point. Humans and dogs share a point further back. So these 2 are more like each other. Okay? If I say to you, what's more like humans? The mouse or the fish? Use the exact same logic. The mouse and the human are connected by this branch point. The one that is basically higher up the tree is the one that you look at. Whereas the human and the fish are connected by this branch point, but that branch point is further down the tree. Okay? So if it's further down the tree, the more distantly related. So your job is to make 8 trees. Now, why 8? Like, well, shouldn't it work with 1? You're going to be stunned to see something that you might not have 8 trees that give you the same information. You could very well get a tree that has dogs over here, and the tree might say that we're closer to rodents than we are to dogs. Because you got to understand that we are looking at one protein. We're looking at just one protein. And it could be by coincidence that that protein gives you a result that's unexpected. So the reason why I want you to make 8 trees is because what you're going to do after you do your 8 trees is you're going to look at what's the most common pattern. If I get 8 trees and 6 times out of 8 it says that dogs are more like humans than mice are, then I can probably say with some confidence that dogs are more like humans than mice. But if I only do it one time, I could actually get an information that's incorrect, okay? So what we're going to do is we're going to do 8 trees plus 1 more. You're going to build what's called a master tree, and you're going to look at basically what is the overall pattern. So what I would suggest that you do is, starting today or tomorrow, is you have a list here of proteins. Now, we just use Sonic Hedgehog. Here's a list of proteins. Here's another one, cytochrome C, which I think is listed here. Okay, pick 8 of them. When you pick the 8 proteins, make sure you use the 5 same organisms. Okay, so if you're going to use humans, chimps, dogs, mice, and zebrafish, you got to pick the same organisms all the time, because then how are you going to compare? No, that's part of the problem. When you do a blast, you might notice that, like Sonic Hedgehog gave us a pretty big list. You could come across another protein that gives you a much smaller list. But make sure that it has the same 5 organisms, okay? Alright, so that's it for explaining how to use the program. When I come back on Friday, we'll talk a little more about what then to do with all of the results, okay?